Hey, welcome back. I'm shooting outside today just for a change of view, but in this video, I want to share one of my early works regarding automation and importantly, why I did it. What was the main issue I was trying to solve? This was in the early days of my learning and dabbling with software development, sometime 2016, 2017, around that time. In particular, it's about ACI column interaction. So for any of you other structural engineers out there who work with RC, reinforced concrete design, you know how it can be tedious to work with column interactions. Also, how I would want to rewrite it with proper architectural considerations, meaning to be more intentional about it and not just letting the code evolve naturally. So I hope you pick up something valuable and let me show you the actual work.
So here it is, and the first thing you will notice are the series of interaction diagrams here. Each one is based on the combination of two things. Number one, the bar diameter, and the number of bars on each face. For example, 3 of 20s, what we selected right here, looks like this in my drawings, and so on. Together, they form the design space in a visual manner, looking at the interaction diagrams. Next are the common input parameters such as size, material properties, etc. Changing any of these should give us instantaneous feedback after clicking this column interaction button, and the design space would change after that. Unfortunately, last time I checked, this wasn't working. But anyway, this is one of the earliest automation tools I ever built. It's a small VBA script inside Excel. And just walking through quickly through the code base. This might not be interesting. It's just how I structured my code earlier. Less than 300 lines. And looking at it now, there's really plenty of things I would do differently. Although I already had some sense of separations of concern and basic modularity.
However, it makes me smile that this tiny script contains the beginnings of the architectural thinking I use today. Now let's talk about the problem. Why? Why did I build this in the first place? Around that time, I was self-employed and most of my projects are fixed fee. My incentive was to remove repetitive work so I could focus my efforts on more valuable tasks, the actual engineering problem, the actual engineering tasks. I was working with a number of RC structures, reinforced concrete, around this time. And if I recall correctly, I already automated my post-analysis workflow, which involved the extraction of results, then processing the summary. I did this via a third-party structural software API, which is also something I'm planning to share. So let me know in the comments below if you are interested in this topic. So from this, the sectional design became the bottleneck. Usually when you design column sections, you group them based on the size, then work on the reinforcement configuration and quantities. By the way, this is from a force-based or capacity design method. Depending on the number of columns in your structure, the number of designs you need to produce could grow very quickly. And that can be a tedious process. Others may find alternative approaches such as limiting the number of designs and try to fit the demands within certain envelope solutions. Well, such process is inefficient in terms of design outcomes. In many cases, the quality of the design is less dictated by your skill. It is more dictated or limited by the options you can practically explore. And this is a wonderful insight. If exploring alternatives is expensive, naturally you will be conservative. But if exploring alternatives is cheap, you naturally explore more. And exploring more alternatives can lead you to better outcomes. Speaking of better outcomes, please don't forget to press the like and subscribe button below. Now let's jump on the architecture.
All right. We will rebuild this so that it will be reusable outside of Excel. Usable for different workflows, different tech stacks, and even different UI. That means designing it around clear contracts, input and output contracts, and not around the specific tools such as Excel. So starting with these core design principles. The idea is simple. Treat the engineering logic as a self-contained engine and everything else as a client. That means standardizing these input and output contracts. Instead of relying on Excel ranges or cells, we will design them explicitly. They can be represented as a JSON or CSV. The point is any type of structured format. And the important part is that the engine, which is the agnostic core, by the way, only cares about the contract regardless of where the data comes from. So let's talk about the agnostic core. The agnostic core, it will have the clear separation between the engine and integration. This way, the same core logic can be reused in multiple contexts without modification. So our main problem or the main concern of the agnostic core is given a defined section and a sampling definition, we calculate the corresponding axial moment interaction points. Zooming into more details, these are the individual responsibilities and contents of these components. So again, the core doesn't know or care whether the caller is Excel, a terminal, or whatnot. It just receives input, executes, and returns output. So it's worth mentioning the exclusions right here. The agnostic core will not contain the Excel ranges. It will not contain the demands or any type of load combinations, any project workflows, and especially engineering judgment. And going back to the contracts, these are typical input, input output, which can be consumed by any client, as I mentioned. Now on to the high level components. This is the existing state of the Excel VBA script. We have the reinforcement data, the spacing checks, the neutral axis loop, stress reinforced calcs, let's call them the core function, the interaction table, and the visualization component. So the code is not big, but there's too much responsibility that everything is tightly coupled within the Excel VBA environment. So we will build a new core engine with the following components. We will have the reinforcement, which is a proper data structure to represent the reinforcement layout and properties. Again, the core function, which will contain the stress strain calculations, the axial moment interaction calcs, and other supporting engineering logic. Also, we have the spacing checks. We will separate the spacing checks required by ACI code, or maybe perhaps we will build this as a more generic component that could encode different design code or design standards. And finally, the neutral axis loop. So why this matters? Why is it important? By rebuilding the core engine this way, it would be reusable and testable. That's an important thing. Easier to maintain, and this is one of the things I like about it is it's less opinionated regarding the workflow. We also standardize the input and output, and finally, it's tech agnostic. So in the end, it's still solving the same problem, but now it's easier to maintain, easier to extend, and easier to share. And then around it, we can design adapters and integrations like the reinforcement config on the input side. And we could consider also add-ons around it, like the demand capacity checks or the utilization or DCRs, utilization ratios, visualization component. We can also build that any way we want. And of course, most important is the validation and verification. And this is where it gets more exciting. We can have any type of client or orchestration layer. For example, you can call it from a CLI or from an AI agent. This is something I personally love to implement also down the line. And other means importing it through a library, use it in a script, a web service, or you can tie it back to Excel if you still have the rest of your workflow inside Excel in other Microsoft products.
Looking back, I was just aiming for speed, but the automation revealed much more. It wasn't just about the speed. It's also about expanding, being able to expand the design space to be able to explore more alternatives to arrive at better outcomes. In the next video, I'm going to walk you through the implementation of the architecture that we discussed earlier. If you're interested in that, I hope to see you there. It will be more hands-on. See ya.